సో ఈ వీడియోలో మనం ఏం చూడబోతున్నాం అంటే టైం పీరియడ్. సో ఈ మాస్ స్ప్రింగ్కి అటాచ్ అయింది కదా, దీనికి కొంచెం ఫోర్స్ని అప్లై చేసి వదిలేసాము అంటే ఏమవుతుంది? ఇమాజిన్ యువర్ సెల్ఫ్. సో అది ఆసిలేట్ అవుతుంది కదా, టు అండ్ ఫ్రో మోషన్స్ చేస్తుంది, బ్యాక్ అండ్ ఫోర్త్ ఇలా. సో ఈ వర్టికల్ డాటెడ్ లైన్స్ ఏమి ఇండికేట్ చేస్తుందంటే ఐఎమ్ టేకింగ్ ఇట్ యాజ్ అ మీన్ పొజిషన్ or it is going to be there at like relaxed state. ఓకే, జస్ట్ న్యాచురల్ లెంత్. అప్పుడు స్ప్రింగ్ ఉండే లెంత్ని ఏమంటామంటే న్యాచురల్ లెంత్. ఇది రిలాక్స్డ్ మీన్ పొజిషన్ దగ్గర ఉన్నప్పుడు స్ప్రింగ్ ఎంత లెంత్ అయితే ఉందో దాన్ని న్యాచురల్ లెంత్ అంట. యూ గోయింగ్ టు కాల్ ఇట్ యాజ్ న్యాచురల్ లెంత్. అంటే స్ప్రింగ్ నైదర్ ఇన్ కంప్రెషన్ నార్ ఇన్ ఎక్స్టెన్షన్, దాట్ లెంత్ ఈస్ natural length. But now in the second diagram, if you observe, it is more than natural length, right? Means maybe it can be in a compressive or extension. So but you can see here, right, it is in extension state, not in compression, because if it is in compression it can be less than the natural length, that we can observe. Okay, how much it is extended? Just you can see it is extended x distance from the or displacement from the mean position, because it is straight, right? In a horizontally it is there. So here in this case distance, displacement both are equal. Now what you can observe, x distance లేదా x డిస్ప్లేస్మెంట్ అనేది ఏమైంది, డిస్ప్లేస్ అయింది. అప్పుడు ఫోర్స్ అక్కడ వదిలేసిన తర్వాత ఆ స్టేజ్లో ఉన్న తర్వాత మళ్ళీ వెనక్కి వస్తుందా? ఎస్, ఇట్ విల్ కమ్ బ్యాక్. సో హూ పుష్ ఇట్ బ్యాక్? మనము ఫోర్స్ అప్లై చేసి దీన్ని ఎక్స్టెండ్ చేస్తే అక్కడికి వెళ్ళింది. We applied force, that force we are calling is external force because we applied it. Next, why it comes back mean it has the spring force. So what is that spring force? F equals to minus kx. According to the Hooke's law, okay, Hooke's law, force is directly proportional to displacement, and that is in a negative direction, because you can see here displacement వచ్చేసి రైట్ సైడ్ ఉంటే స్ప్రింగ్ ఫోర్స్ ఎలా ఉంది, లెఫ్ట్ సైడ్ ఉంది. బోత్ ఆర్ arrow marks you can observe quite opposite, right? That to indicate here we have minus, right? But for removing this proportionality we are going to have F equals to K, minus is common, F equals to minus kx. But from Newton's second law, what you can write? F equals to ma. That relation you can write here. So if you write it, F equals to ma, and now F equals ma equals to minus kx, that is nothing but F. So what you are doing here, you are doing the comparison of spring force and some force from the Newton's second law. So from that what you can write here, A equals, how you can write? A equals to double rate of change of displacement, acceleration, d square x by dt square, because it is this displacement is happening in a horizontal direction, that is x you are taking, that's why d square x by dt square, the rate of change of velocity or double rate of change of displacement is going to be the acceleration. That's why what I am going to write here, m into d square x by dt square, I am writing it dt square, that equals what, minus kx. But I don't want to have here mass, that's why what I can do, divide the entire equation by m. So if I divide it, m into d square x by dt square equals to minus kx. Okay, I am dividing it, divided by m, here is also divided by m. So now what I can find in the left side, gets cancelled, right? Both are going to get cancelled. It is going d square x by dt square, that equals to minus k by m into x. Just I won't write like this, that's why I have written it, because m is dividing the product of kx, but I am writing it k by x. Instead of d square a by d square x by dt square, what I can write? I can write it as acceleration. Now we know simple harmonic motion. Simple harmonic motion, the condition, one condition is a equals to minus omega square x. So if you compare these two equations, equation 1 and equation 2, what you can observe? A equals to d square x by dt square, right? So minus minus also you can compare, x you can compare. What is going to be here? The omega. Omega is what? So that we need to understand. Omega square equals to k by m. K by m. And from that, if I want to write omega, what I can write? Square root of k by m. Square root of k by m. And now what we have to calculate actually? Time period. Time period of oscillation. That spring is making, right, oscillations. What is the time period for that I want? So time period equals to t equals to 2 pi by omega, right? It is going to be 2 pi by omega. So what you are going to write it? So omega place emundi 2 pi by omega square root of k by m. Now that is if you write it 2 pi into square root of m by k. What is this m? What is the k? K is going to be the spring constant. K is going to be the spring constant. If that spring has the constant value, this spring has constant k value it has, right? That k value is more, what will happen? K value is less, what will happen? So if k value is more, the time period how it is, you can compare. Let us write that again, the final equation for a discussion. 2 pi into square root of m by k, right? The relations, if I want to write it, I can write like this. What I can write? By the is they are they directly proportional or inversely proportional? You can think of it, right? So t is directly proportional to root m, and now t is inversely proportional to root k. Means if mass increases, mass of that body which is attached to the spring is increased, what will happen? The time period for completing one oscillation or time period of SHM is going to be increased. So if mass is increased, time period is also increased. Now I am talking about time period, and another one is here spring constant, right? Spring constant. If I decrease the spring constant value, time period is going to be increased, because these two are inversely proportional, right? That's why what is happening to this mean time period, when you are changing mass, when you are changing spring constant, that you can understand it. So when k value is more, what is the meaning of that? If k value is more, it is more stiff, means you can't make it extend very easily, right? If k value is less, you can extend it easily, means you can apply less force, but you can make the spring to elongate more. Like if k value is less, you can say that spring used in a pen, spring used in a pen, right? So why? Because we have to apply less force, and it has to work. But whereas stiffness is more, that k value, like what I can say, springs under lift, right? లిఫ్ట్ వర్కింగ్ ఉంటుంది కదా, దాని కింద కొన్ని స్ప్రింగ్స్ ఉంటాయి. ఆ స్ప్రింగ్స్కి కే వాల్యూ ఎలా ఉంటుంది? ఎక్కువ ఉంటుంది. అప్పుడు టైం పీరియడ్ ఎలా ఉంటుంది చూసుకోవాలి ఇక్కడ. సో దాట్ యూ హ్యావ్ టు అండర్స్టాండ్. సో మచ్ యూ హ్యావ్ టు థింక్ అబౌట్ దిస్, అండ్ వీ హ్యావ్ డన్ దిస్ స్ప్రింగ్ మాస్ సిస్టమ్ and time period calculation by using what? By using the force method. By calculating the force involved in it, we have done this, right? but by using energy stored in a spring, okay, by using that also we can do it. That we will do in the next video. Thank you. I hope you understand what is the importance of this and terms involved in it.